Welcome to the WaterSim Arizona model. As population and citizens' demand for water increases, it is imperative to have policy choices that positively impact the future of water in your region. Through this model, you can understand various stakeholders and how to decide how much river and groundwater they should use, and how much they should be asked to use water more efficiently. The model is broken up into 5 different regions around Arizona. Ensure that you are using the correct region. You can select your region by clicking the wheel at the bottom left by the Run Model button, then using the Geography drop-down menu to pick your region. Mojave, La Paz, and Yuma counties are in the West model. Maricopa, Pinal, and Pima counties are in the South Central model. Greenlee, Graham, Cochise, and Santa Cruz counties are in the Southeast model. Gila and Yavapai counties are in the Central model. And Coconino, Navajo, and Apache counties are in the North model. There are a variety of categories of policy choices. You can learn more about each of these by clicking the Information button near the end of each Policy Choices row. Under the Water Source Availability category, which is the amount of water that can be used in each source, there is surface water, which would determine the amount of stress on rivers and streams, groundwater, which would determine how much groundwater is saved for other times, and reclaimed water, which trades off with groundwater and surface water. The efficiency of water use indicators are shown here. This includes cities and towns, which demonstrates the overall net impact of policy choices on urban and rural water users. It encompasses a range of factors that include, just to name a few, comfort, lifestyle, and overall water use by residents and local businesses. There's also agriculture, which represents how well your farming and agricultural neighbors, and perhaps you, are doing in the future. There's industry, which represents how well your industrial players such as mining, military, defense, healthcare, and tourism are doing in the future. Lastly, there's electricity, which represents how well your power plants are managing their water. For these meters, green indicates that there is a balance between water use efficiency and consumer comfort. As these meters move to the left, water use efficiency increases, which means that less water is being used by the consumer. This can put a strain on consumer comfort. As the meter moves to the right, water use efficiency decreases. The amount of water used by the consumer increases, which increases consumer comfort. There are several different clues as to how balanced your policy choices are with your model's data. First is the sustainability indicators, which are scales of how well each sector in the model is doing. These include, first, the economy, which reflects how well the overall economy is doing based on chosen policies. Second is the environment, which provides an indication of how well we are managing the riparian ecosystem along our river corridors. Sufficient water in the river helps to maintain healthy plant habitats and viable animal populations. If we use too much surface water, then less water is available for these plants and animal communities. Lastly is groundwater. This provides a snapshot of future groundwater sustainability, as in 2050, and are we pumping more water than we are recharging, which would be unsustainable, or are we in balance, which means that groundwater pumping equals groundwater recharge. Learn more about each of the sustainability indicators by clicking on the icon. Next up, the assessments category shows how you can improve your policy choices. The assessments categories that are not in green, so they're yellow or red, will provide insight as to how supply and demand can better be balanced in the model. For example, the assessments can show where water is being wasted so that corrective changes can be made. The main chart on the front page is called a Sankey diagram. The Sankey diagram shows how surface, ground, and reclaimed water are used with current policy choices. Exact numbers can be viewed if you scroll over the color in question. Click the Bar Charts tab to see a different view of the data. The consumer's total demand chart demonstrates how many millions of gallons per day each consumer demands, as well as how much of that demand is being met in blue and what is not being met in red. The Resource by Consumers chart is another way of visualizing how consumers are using surface, ground, and reclaimed water. Lastly, this line chart shows a timeline of how many millions of gallons per day each consumer demands. The default screen when you open the model is not balanced between water supplies and demands. It can be helpful to play around with the model's settings to see what balances the model best. The model does not automatically change with each policy change. You have to click the Run Model button each time. You will notice that the policy choices you make creates trade-offs in the system. For example, increasing the amount of surface water available may help agriculture, but it may make your environmental sustainability indicator decrease or go into the red zone. You can see how changing my policy choices affects the indicators and graph. WaterSim Arizona keeps all climatic and drought conditions constant. You can manipulate the level of drought in your area and how drought affects your policy choices. Click the Drought tab above your policy options to change the severity of drought in your area. Hit the Run Model button to see the impact of drought on your scenario. In the Settings menu, accessed by clicking the small gray cogwheel near the Run Model button, you can create various settings and scenarios. Click the Region Map button to see a more detailed map of the watershed or region that this model is based on. You can save different policy choice scenarios as well. Once you have created a supply and demand balance that you would like to save, click the Save Scenario button and name it. Then, this scenario will appear in the Derived tab. You can also click Load Base Scenario to go back to the original screen for a fresh start. When saving scenarios, note that they are saved within your browser and will be lost when the browser is closed. Creating a report allows you to create a printable version of your scenario. This is a good choice if you need to close your browser but want to have a record of the scenario settings. Click the Create Report button. From here, you can print from your browser. Also, check out the Credits button to see all the partners and people who brought this model to fruition. Let's go through an example scenario. To attempt to satisfy the demand of agriculture, you could increase the amount of surface and groundwater, and keeping the amount of efficiency the agricultural industry has to have at the No Change option. The effect of this can be seen by clicking the Run Model button. These actions brought us closer to a supply and demand balance, but it did have consequences. For example, the groundwater sustainability indicator is now closer to the red zone. If we wanted to have sustainable water use for the environment, we would decrease the amount of surface water and groundwater available, increase the amount of reclaimed water being used, and increase the efficiency for our industries and consumers. Once clicking the Run Model button, you will notice that the groundwater sustainability indicator improved, while the economy decreased. Continue to try different policy options and see how they affect the sustainability indicators, assessments, efficiency of water use indicators, and the balance between supply and demand.